Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, I'm Ed.
Hey, I'm John.
And, this week we are going to continue down the road of, filament types. We're going to get into more of your intermediate filament types and also get into the sustainability of those filament types. But as you heard in the introduction, we got Ed back. And we're not doing this remotely, so we're actually everybody's together for once after a little bit of time. Everybody had their stuff going on. So, want to let Ed kind of spitball his idea on the beginner filament and the beginner filament kind of like recycling side of the house and sustainability side of the house when we start talking about beginner filaments.
So I would say, most of us are familiar with PLA, and I would say PETG are probably the two beginner. There are other filaments that you could possibly use, but you're probably looking at a skill level. Mm-hmm. So I would say at a basic skill level, you're probably looking at PLA first, and then after you've gotten used to the characteristics of PLA, you probably say, well, hey, I want to try PETG. Where PLA stops, PETG starts as far as temperature. Mm-hmm. So it is a difference. Right. So. Mm-hmm. That's really what I would say, far as from a beginner. So PLA is a little bit more user friendly. It's probably straight out of the box. You can use PLA and start printing things. Mm-hmm. PETG is probably going to take you a little bit of getting used to. Going to have to do some adjustment on the bed temperatures. You might even want to look at the speed of your fan or cut the fan off altogether. So you'd have to look at some of those things. Maybe
your
look
bed
at
type's going to take a big hit on that. Do you want it part of the bed or not part of the bed?
And then, one of the things I've seen, like some tips or some advice I've seen, is people use glue sticks for adherence because PETG does have a tendency to curl sometimes if that first layer doesn't.
Or PETG has the ability to become one with its surfaces being printed on.
Yeah. So I think that's the piece, and I don't want to segue too far. Mm-hmm. First layer adhesion, important,
definitely
needed. I think though that. Or at least the way it was explained to me, is that the glue stick is less so after the fact about
removal,
keeping it on the bed, but it's about the removal.
Yeah.
Because if you can create a layer of another substance, I think this is mostly with PETG on glass.
Yeah, it creates an air gap.
Yeah, it becomes part of your
it's
part
like
of the
printing
glass.
on tape.
So if you do tape, that's also another way you can kind of get the kind of adhesion to stick if you're having adhesion issues. Mm-hmm. But at the end of the day, most people try to pride themselves on not needing it, but
we talk
you need
beginners.
An activator. You need something. Need something that's going to make sure your adhesion happens.
Right.
If we're all truthful here, I've used all of them.
Yeah.
Hairspray.
And I'll definitely say this: do what you can not to print PETG on glass.
Yeah. Well, like I said, if we're talking beginners, like most beginners not going to use a glass bed. Most beginners going to use what come out of the box. So we just talking beginners. Yeah. Most beginners going to pretty much just be, hey, I'm put the spool on there and try to print.
Yeah.
And then fail. And then we're like, oh, well, why did that fail? So I'm just saying, we're just saying from a beginner, not to go too far down the depot, too deep down the rabbit hole. I'm just saying from a beginner, those are probably the two things.
Yeah.
Then from recycling and sustainability, you have to, do some sorting if you're going to do PLA and PETG together, because PETG needs to be separate.
Otherwise, you're making a new.
We'll take a glycol one.
So those were the things I would say to consider. If you're producing a lot of waste, maybe, like I said, you sort them in bins. Maybe you can, make some type of, or there are a couple of kits I've seen that you can buy where they make shredders that are made specifically, basically like a paper shredder, but they're more industrial, and they basically can break the plastic down into smaller pieces, and that could be something maybe you can more easily send to someone to recycle for you, because it's going to kind of be difficult for a beginner to do any type of recycling in the beginning.
Right.
Filamentum is one of those companies that'll take care of that for you.
But that's all I really got from that point of view.
Now we start talking intermediate. Intermediate, I think, is the fun stuff. As you heard, bring up Filamentum. Filamentum is one of those companies that we've talked to in the past. Hope to establish a good working relationship with those guys and actually have them on the podcast and talk to them. They do a lot of the filament recycling guys. They're really cool.
They're based out of Sweden.
They are, and they're good. They're good people. No, Czechoslovakia.
Czechoslovakia. That's right.
They have an office here in the U.S. that does their U.S.-based recycling stuff.
Right. We learned about them with the fishy filaments.
Yeah, fishy filaments.
Recycling.
Which is absolutely awesome. Old fishing filaments. It's just pretty much PEI at that point, or nylon.
Yeah, if you could reuse it at any point, why not?
But we start getting into your intermediate fun stuff. This one I think we're gonna have some fun with, because it's really depending on what do you think is intermediate, what do you think is more or less on the advanced scale, because that's when you start really getting into hardware dependent filaments versus non-hardware dependent filaments.
Yeah,
that I think it makes kind of the decision, at least easy for some not so much. You start talking any of the pluses, I guess you could say. Then you start getting into ABS. ABS, I think, is, to me personally, my own feelings, is ABS is an intermediate filament because it requires a heated chamber, or at least an enclosure for that matter, and it requires a little bit more heat. But any printer, basic printer out there can print it. You have a setting on an ender for ABS. Guess what? You can print ABS. Put a bag or something like that around your printer, so you don't get the curl issue.
Yeah, they sell tarps.
Yeah,
little
exactly.
Small enclosure things. Yeah.
So it's a beginner friendly filament on beginner equipment. Right. It's an intermediate filament because you have to understand heat and curl and all the other fun pizzazz.
Yeah, I mean, I think I agree with you on it. To be honest, ABS toes the line. TPU toes the line.
Yeah.
For me, it's the reason I say it toes the line is that for an enclosure for ABS, you're just putting one on there. You're not trying to change the temperature at all.
Right.
So at the end of the day, you're not controlling it so much as you're keeping it constant.
Right.
Right. So for me, if you're heating the chamber or doing anything like that, you're working towards actively taking water out of the atmosphere, the environment of the enclosure of the printer. So for other materials that we would get into in a more advanced stage, which are like very hygroscopic, and they absorb humidity out of the air, as opposed to some of the other materials that completely avoid water, anything like that. Like what is it, non-transmissible? But we looked it up earlier. Polypropylene is not transmissible, so it won't absorb the water. It may take a little bit of water into it, but it's not going to let the water transmit through it. Things like that. So I also think that enclosures are required for that.
Yeah, it's non-permeable substance.
So we have a whole bunch of things that we can kind of work with. You talked about the pluses. So I think that I can kind of split this on two trees on this side of intermediate, right? Mm-hmm. So intermediate being, I need to have a very large working knowledge of the temperatures. I need to be comfortable with printing on certain temperatures, certain materials. I need to know what my nozzles are made out of and stuff like that. And then you get the other step is where, okay, you need to know all those things, but I need to make an active change to my system in order for me to be able to attain this. So like ABS versus ASA.
Yeah.
ASA, higher melting point. It's going to be more durable. However, it's a lot more difficult to get to the glass transition that you need to have that first layer adhesion. So there's an added layer of difficulty, and probably it's going to wear and tear on your other consumables that much more. So you have to, it's something that there's a reason that it's a little bit harder to get to, and the reason why I would even, some people call it engineering materials, because the engineers are making these materials or synthesizing these materials for specific purposes. The PLA Plus, the PETG Plus, I would say those are created by companies to solve bridge a gap and solve a problem that they may have solved with maybe it's the rigidity is too much in their snapping. Maybe it's not adhering to each other. We need to add little bits of this. Maybe I just need to change the color, but that's also adding an element to change the composition. So there's a lot of things that go into those, and when they go into PLA Plus, there's another type that my brother swears by. He calls it Meta. Yeah, so it's something that I would relate more to a PLA Plus, a PETG Plus, but the durability, and I think a key word for a lot of people is consistency. Like for me, Solutech is what I started. 3D Solutech. I really wanted to go American. Yeah, it's a good brand. I wanted to start American. It's easier to get because it's American. It's cheaper to ship it. And this one, no matter the color, as long as I got PLA, exact same print, exact same settings. That type of consistency is what I'm looking for in a print. So if I'm a beginner, that's what I'm going to stick to. If I'm an intermediate, I can I know how things behave, so I can take those audibles, let's just say, and say, okay, my TPU is not printing because I don't have a dual gear extruder or a direct drive. So it's rubbery and getting pushed and just getting wound into a ball around the stepper. I could see that. I don't have to do 10 prints to know maybe I need another metal extruder or dual gear or all direct drive. So that's kind of one of the best experiences or explanations or examples for me, because I printed TPU and all I did was get a metal or aluminum instead of the plastic extruder, and it started working.
Yeah.
Also, it was a dual gear. I think that helps, but it's one of those things where it's consistency is why I was using it. I used it to make cup holders, coasters. You can put like little friction pads underneath tables, like end tables and stuff like that. It's perfect for a lot of that stuff.
Yeah,
make phone cases.
Yeah, that's the same reason I went to Sunaloo for all of the white filament that I use.
Yep.
For
consistency.
It's this every time I plug it in, I throw it through the printer, I hit the go button, and guess what? It's going to give me the same result every single time.
Yeah, and repeatability is really what you want.
The thing is, it's come down to any color that they make like that. The same thing with like PETG, for example, like what you're talking about being a beginner filament, which is I use G-Tech. I don't know why, but I do. That's why I started out with, I bought 2 rolls of it.
There's hundreds of brands, yeah.
And it works. It worked from day one from the get-go. Some of the other stuff they make, not so great. But, at least I know their PETG is a little bit better than most.
I would say you may be able to contribute some of these things to the brands, because maybe the brands were some of the first brands that
Right.
Well, I mean, I would even go
a secret formula
a little further than just the material, the composition of the material.
Yeah.
I would even go as far as that maybe these are some of the materials that the original or the first companies that started to build desktop 3D printers, that I would argue that the settings have been dialed in and such to those materials, because those were probably some of the materials that they prototyped the machine. So I think that's a factor that also may contribute to the slicer. I think the slicer is probably firmware and the slicer are probably the 2 most important things, I think, for a desktop 3D printer. The other things, like we said, the mechanisms we use to deploy the filament through the system is very important. The materials we use to, I would say, direct how that the filament is processed in layers makes a big. But I think if, like, say for example, some of these major players use some of these things to develop, then I'm thinking that their models are kind of accurate. And with the composition of the companies that you said, and the confidence that you have that they produce a product that's the same over all of the brands they make,
I can wholeheartedly agree with that.
It's consistent. So for me, intermediate, I think just from a person that's looking at 3D printing from the horizon, as opposed to the person in the mountains. From the horizon, for a basic person out of the box, I would say intermediate would probably be nylon. And I would say it from this point of view. Intermediate for the machine, and then I think that's the big step from PETG, and even the one you're talking about, ASS and ABS. I think the step is when you start going to nylon. ASA, I'm sorry.
Yeah,
but when you jump from
Oh yeah, you can't. You
Yeah,
can't say
ASA.
that.
but
Like,
when you
oh, yeah.
but when you make the jump from like say like your PET PLA and PET G to nylon, I think now you're starting to use concepts from an engineering background.
Yeah.
Because it's not as simple as push the button and go.
Right. And I think, to be honest with you, that this goes back to the fact of getting people into STEM, getting people into 3D printing, getting people actually enjoying the makerspace, getting them into engineering. I think once you get them past the PLA and the PET Gs out over the world, you get them to the ABS side of the house. You start getting them into like the ASA side of the house. You start getting them into, the polypropylenes, because I could probably say polypropylene might be an intermediate if you have the heat to do it. Most printers out the box do not have the heat that are capable of hitting that.
What are you talking?
260.
260?
The bed temps all day. Bed temps and indoor can print the darn thing. The actual temps coming off the nozzle, actually no, it might be closer to ABS temperatures then.
Yeah, I think. I mean,
if you think about it,
I'm trying to print so I have a real life example. So I'm trying to print polycarbonate.
Yeah.
Right.
So you just went freaking gung ho for the top of the liner.
It's more of a challenge to just print a damn benchy. Like I just want to print a benchy.
This is also what happens when you go into a store and you kind of get a squirrel moment and you just grab whatever looks shiny.
And you're like, hey, what's the hardest filament you have to print? This one, give me it.
You don't want John to find it, put it on the top shelf.
Yeah, I'll find a step stool. I'll climb the shelf. I'm not above climbing the shelves. You'll see me in Walmart climbing the shelf. I'll get what's on that overstock spot, especially since it's 101. But no, so there's a reason. I went after it just not just to prove a point, but that we're pushing our knowledge, we're pushing our understanding, we're trying things out. We've definitely not tried all the filaments, of course. There's
I may order some polypropylene just to try it.
You probably have better options on the Voron because it needs an enclosure. It sucks humidity out of the air like no other filament I've ever had.
Mm-hmm.
My biggest issue is bed adhesion because I think it's 260.
Yeah. And
then my bed is 110, so it's pushing the limits of my printer already. I've already had to switch out my heating element for the hot end and stuff like that. But all these things I'm kind of getting at is because this makes it to me an intermediate to an advanced filament, because it's an advanced filament because I have to be able to see how the bed is. Okay, it's not a bed level issue. It's not a bed adhesion issue. It's a humidity issue. Like, you got to be able to see those things, and then how do you adjust to those? That makes it a lot more difficult. So, kind of when we talk about top level down, high level look in, whenever we're seeing that advanced, I'm thinking, okay, your common issues aren't happening, and you have to deal with things and make it an abnormal environment, or do special circumstances. Like I have a dryer box for my filament that it sits in. I have a Bowden tube from that box to my enclosure. I have an enclosure that the printer sits in. I got a mosquito for Creality from Slice Engineering. Shout out to those guys because everything worked perfectly. It fit in. I have it wired with Clipper. But at the end of the day, I do everything I do for PLA, PET-G, and ABS, and TPU. And it still won't stick. Now, this has only been a couple weeks. I haven't really tried every single day. But this is where we get to that point where it's like you may think you know enough to be able to kind of step into those things, but they're different animals.
Mm-hmm.
There's 4 or 5 added issues, heat creep. So honestly, whenever I'm like, hey, I need to upgrade my nozzle, my hot end, my bed, my extruder, I'm in the advanced category now. And this is not a basics or intermediate at that point. If I've had to replace every part on my printer and build a new printer, this is advanced. Mm-hmm. So I guess that's what I would say. So advanced to me is I can make settings changes and make it work, but there have to be more precise in things that I've never worked with before, like rotational distance in Clipper is literally just flow rate.
Yeah.
So the rotational distance of your stepper. But whenever I have to change everything and still do that, advanced.
And it's, just to hit on our PP, our polypropylene topic real quick before before we
Yeah,
make that sound weird.
To say that right.
Is
too close.
the hot end temperature?
Yeah.
For polypropylene is 200. It's 220 degrees Celsius.
It's not bad.
Your bed temp is between 45 and 65 degrees Celsius.
That's not bad.
And the thing is what I'm finding, just doing some little side research here, is like this one I'm looking at off of Amazon and stuff like that. No drying is required to actually to use this filament. So you're not required to actually dry the thing. So it's not hydroscopic. It's not going to suck in water from its own environment. So technically, it's about on par with printing ABS, but you know, ABS for me, I throw it in an enclosure, dry it out real quick to print with. But it's not required to go through that process.
Not everybody has a heated enclosure or has an enclosure that they can. Well, you heat the bed to it, I guess that makes sense.
Yeah, and it's kind of you kind of make one.
I mean,
don't throw it in your microwave.
Microwave, no. Conventional oven, yes.
Yeah.
Low temperature.
It's either that, or if you're really careful, you can put it on top of your regular bed that you have. Just heat it up a little bit. Put a couple, empty spools on top of it, and it'll dry itself out.
Walk in a couple minutes, flip it over, make sure you keep it even heat.
Yeah, it's kind of like it's like kind of making pancakes.
Yeah, there you go.
Yeah, I think the big thing, like when we talk about desktop 3D printers, in general, like say some of the things that we're talking about as an org is. We're looking at things that's building things that can be like for different type of applications. But I think most people that get a desktop 3D printer, I would say one of the biggest growth areas right now is the people that do cosplay. And those people, like, they don't care if they print nylon or they don't care if they print. Like, they basically stay at that beginner. Intermediate for them might be that they make a multi-part piece, and they have to do some dimensional things in CAD to verify that those parts fit together. Like I watched Tested, and they did I
can see that,
a 3D model where they printed the 3D model in different portions.
Are you talking about the
new game?
The new game,
yeah.
Have you tried it yet?
No, I haven't.
Oh, okay. I need to find somebody who has. I haven't tried it yet. Yeah.
I haven't played it. I have friends that have played it. It's.
Sorry,
I don't want to.
But
yeah, I mean,
curiosity.
To be fair, I play games. I don't want to say all the time, but I do play games here and there. I enjoyed Fallout and Skyrim and the same company, Bethesda.
Yeah.
It's the same. It's a new narrative in space.
Yeah.
The one thing I don't like. I'm not flying my spaceship like I wanted to, but there's another game similar called No Man's Sky, and that's more flying around if you want a spaceship. So hell, you can do Microsoft Flight Simulator.
Well, the thing is, for example, when it comes to the flying stuff, I've played on the Xbox One, I've played the Star Wars flight game that they've got now. And for me, I think I'm not a big gamer.
I think that's cool.
Yeah.
I think I pretty much use mine for streaming or now as a doorstop. Because
probably be like a club.
Too busy working.
It could be a work.
Too
busy working to pay for it.
Yeah, too busy making everybody else money to actually enjoy it. But it is what it is. Hopefully, I'll break that process soon. But I might try it one of these days because it looks interesting.
Yeah. Well, the thing that I took from watching the episode, and this is I like watching Tested.
Oh yeah, definitely.
He's usually always on TV.
And I think that his content is really great. But one thing he did is his group they made this model, and the model was in pieces, and they actually did all of the design and the I would say the CAD work based off of drawings. But the point I'm getting to is that probably is the extent of, say, a person that's a maker for a cosplay, or a person that's a maker that makes dioramas or something. They may not ever go beyond the basic. I believe the people that go beyond the basics is, hey, I want to print a hull for a drone. Okay. And now you start to say, well, hey, PLA is okay for a prototype, but PLA is not the solution for something that I want to be durable that I can fly and it's going to collide into things. So
is there
I think
impact points and things like
that's
that?
where the transition happens between the basic and the intermediate.
And I think he during that same episode, because I remember watching that episode, is they kind of, and he even made a mention of it, that, as they move forward in, I guess you could say, movie effects, the SFX world and stuff like that, is the fact you're going to see more and more and more 3D printers get involved in this process now, because it shortens the time to movie. And he said that, the other thing that he noticed is the fact that we're going to be using a lot more of our resin printers to get the small stuff that we need to get, while all your impact resistant special effects and stuff like that can all be done in like ABS or something like that. So it's not as.
And to be fair, it was a resin.
Out.
It was a resin print that they did.
Yeah, I remember. Yeah,
it was.
Some of the
it
stuff
was
was
resin.
FDM.
Yeah, a few things, but
the actual shape of the ship was all resin. Yeah.
One of the cool things, like I said, we're getting a little bit off topic. And I want to get us back, because I tend to take us to the left sometimes. But they had a LED controlled wall that was built on panels, and the panels just pop out and pop in. But the resolution on this panel, they were able to get 3-dimensional depth from the pixels that they were getting from the individual lights that were controlling these panels. It's one of the biggest LED walls that's used, and it's specifically used for like the film industry. But let's get back on topic.
Yeah. Which I wouldn't say we deviated too far. We're still inside the same zip code.
Well, I mean, to be honest with you, it's you bring up a good point where it's like when it becomes you have to make your files. This isn't something I'm copying. This is something I'm creating.
Right.
At that point, yeah, I think a maker probably, if it's rapid prototyping and just model making, of course they're gonna it's the quickest. They're gonna stay with the basics. There's a reason why we teach the basics first on everything. We've talked about it so many times, but I still call that advanced because I can't. I mean, not everybody can stop and go make a 3D render of a file or make an STL that will work. Everybody can probably hit the slice button, but not everybody can make it. Open SCAD or Blender or Fusion 360, Tinkercad. I mean, just depends on really what you want to do it in, and if you're using any of those applications, I would already classify you as immediately intermediate. Yeah. And if you're making anything successfully, you're advanced.
And the thing is
that's skill level also. Like when we start talking. Unfortunately, with 3D printing, it's not just like you said. It's not just pressing the button. Right. It is a skill level that is required.
Right. Yeah. It's you don't get a lot of the squirrel moments, but the thing is that it helps you get to the point where you're trying to get to. It's like the fact is when you start rolling in, and I know that we'll probably do an episode just on this alone, is the 3D scanners. You start getting like 3D scanner technology. And I'm going to keep this short because we got to do an episode on it. Because there's so much stuff that's thrown into the 3D scanner now from a cell phone.
Wait till we get one and then
to something else.
Adam got his.
Yeah,
he went to New York, and it's a guy.
Yeah,
they're making action figures out of people.
I saw that. I watched that one. But the thing is if you start using 3D scanner and stuff like that, you're in a different category.
You in a different stratosphere.
You're dealing with reproduction parts. You're not dealing with... You took
the modeling all out of it.
Yeah, right.
I'll scan it and get my model.
But even with that, they still have to do some adjusting to the model.
Yeah, they have to clean up.
Yeah, so you still have to have those skills.
We have a video champion scanned it, on the YouTube channel when we were at Rapid.
Think you'd ever give me my file?
Yeah, it'd be nice if the guys from China would actually send us a file for that. But hey,
So it's a bunch of little Johns running around being sold at Kmart.
Yeah, probably.
If I go over there and there's a bunch of little action figures of me, I'm gonna laugh so hard I'm gonna buy all of them.
It's not called John, it's called Jan.
Yeah, and we don't even have Kmart's anymore.
I take that. I take all of them.
It's the Quickie Mart.
Give me everything you have. I need them.
Mr. Pooh.
I'll start handing them out. Jeez.
There's that left turn we were looking for.
Ouch.
It's not,
give me my scanner and my file. I'll promote.
Well, they're charging $5 for a yawn.
Where about I need need my royalties.
You know, but it's the thing is that's bad. The scanning part will set you freaking hand and fist over people.
I think that's gonna,
and it's becoming more affordable.
And the thing is, it's recreation over anything else. Because like if you think about it, for the guys who are doing, like, I have a bunch of friends who are reenactors. Okay, so for them doing like Civil War reenactments, like the buttons themselves, those metal buttons on the uniforms are very expensive. Yep. Especially the guys who are doing like colonial time, or doing the guys who are doing Revolutionary War time. You have these ornate buttons that they have to print or do or make or find. For a bucket of them things, not a bucket, but I guess enough to do a uniform is very expensive.
Yep.
When these guys can be 3D printing or taking these things and printing and using SLS printers to print these buttons, it's cheaper.
And one of the things I've seen that people have done, because they use lost wax methods were one of the things that they use. Mm-hmm. But one of the things that I've seen is they're starting to use maybe like a PLA print, where they make a first cast, and they take that cast and pour it into like a silicone mold, and then they make a mold, and you can do that. But I just wanted to touch a little bit on the scanning. In the episode we were talking about with Adam from Tested, they didn't just have a scanner. They had multiple cameras at multiple angles that took different pictures at different angles, and all those angles were combined into a server, and the server combined all these images to create a 3D image of him. So the technology is going even beyond just a scanner.
And they said the guy who has the idea, it's actually a franchise opportunity, it's ironic, is that they don't use 3D scan technology, they use the software for it. But other than that, it's all just cameras. One giant flash bulb goes off. Guess what? Now you have a camera. I have a picture. You have the 360 camera, and every single one of those images are labeled.
Yeah.
Which gives you your 360 when you mesh them. But
that's exactly what yes, exactly.
So, you know, the thing is once you start getting into that type of stuff, you start dealing really in some advanced filaments. But now we start going back into the intermediate filaments. You know, you're not really talking. I don't know if we would add in like PLA, like reinforced PLA.
I mean,
so
like that.
When we say reinforced, are we talking carbon fiber?
Like carbon fiber, PLA,
I was gonna
carbon
say,
fiber, not, that type of stuff.
I was gonna say I would count that as part of an intermediate, because to print reinforced, I didn't really need any equipment upgrades. I didn't really need any like user or skill.
Just
like,
a nozzle upgrade.
Or if I didn't upgrade my nozzle, I just know I need to replace it sooner, right?
Yeah.
And so it's like we talk about consumables. Everything's a consumable.
Exactly.
So at this point, like I printed, my enclosure, my lac enclosure I have for my enders, it's with carbon fiber PETG, carbon fiber PETG, and it destroyed those nozzles. So I mean, it's come to expect it. You needed probably a hardened steel nozzle to be able to print this without that.
That game was Starfield.
Yeah, Starfield. That's it.
Oh yeah.
Starfield was the game that they designed. With Bethesda, they came up with a model, and that model was actually used for some of the cut screens that they used in the game.
Oh, really?
Yes.
Okay, I need to see this though, because they usually do something pretty. Well, it makes sense though. He's making props for like movies and stuff.
Yeah,
so,
he was at ILM and
yeah. He did a lot of them. I think he did Back to the Future, a few of them and stuff like that.
I think you're right.
He did a bunch of different movies and stuff like that. He did a lot of movies that not a lot of people think he was in.
Let's just say if you're doing that, you're advanced.
Yeah. If you're doing a movie, guess what? You're listening probably to the wrong podcast.
Yeah, you are an expert. You are expert.
Come
now.
teach us your ways.
And
come
by the way,
the podcast and talk to us.
He does have 2 bamboo printers.
Yeah, he does 2 bamboo printers, and then he's got
probably one big headache.
Right. And then he's also got the extra large. Not Formlabs. No, he has he does have the Formlabs.
Yeah.
But he has the precursor to your big size one that you got.
Because he did
Mega. He's got the Anycubic Mega.
And he's been printing helmets with that.
And thinking of what we was talking about, Bamboo now has one that is a micro 3D printer that doesn't even have the Same.
No.
It just like you set up a little apparatus,
Yeah.
and it actually 3D prints a small scale.
Oh,
But it's also the P1 PC now that they have, which is the same thing as their original titanium, but cheaper. So it doesn't have all the bells and whistles.
And they did fix one of the issues. I know we're getting off topic, and I apologize, guys, but they did fix one of the issues with the cloud-based stuff. Now you do not have to use cloud-based. You can take the files and upload the files directly now. So they did fix. They did fix. You know, you got to use their cloud.
And the thing is, a lot of their printers actually will still run on the bamboo system of multiple filaments.
Isn't it 64? I think it's up to 64 different
Filaments, yeah.
filaments
And you
can
hook
be
them together with adapter wires.
incorporated.
Wow. Okay, I didn't know that.
Yeah, you
3D
can.
If you look at 3D printing nerd, it left turn, but we'll kind of get back to it. 3D printing nerd set up, I think it was 120? No, it was like 20 of the bamboo machines. Not printers, but the multi-material units, the MMUs.
Yeah.
And you can network them all together via communication cords cables.
Okay.
And then you pipe them all into one central unit. Then it all feeds off of that.
Okay.
So you kind of have like a center valve, I guess you could call it. Like a proportioning valve for what filament you're going to get next. And it still does the poops out the back, and guess what?
And that is the disadvantage. It wastes a lot of material in the cleaning in the purging process.
The thing is bamboo wants to what they've released a little bit is increase the amount of filament that you have access to. But the thing is, these guys aren't just doing multi-material. You're also now doing dissolvable supports. Yeah. Which can be considered an intermediate filament if you have a multi-material unit.
Well,
if you have a multi-material unit, you're no longer intermediate.
So what I'm just asking. So here's a beginner asking a question. Mm-hmm. So would the soluble supports that you use, say when you do
like
resin printing, is that considered the same technology?
No.
Or
you do have a dissolvable filament.
So it's two different categories.
Yeah, you would use
it's a different filament that you're using. That's why you need the multiple material.
Yeah, you have to run a multiple material unit.
It's a water dissolvable filament. I don't know what type it is, to be honest with you, but you print it with whatever you're printing, and it washes away.
Okay.
A lot of guys, you'll see that when it comes down to they're using like the Prusa XLs and stuff like that. You'll get the guys running duals just to print that. You also get the guys who are running multiple filaments, where it's like an ABS and a PLA if they want to get certain things, or friction zones and stuff like that. They'll print out a certain filament versus another filament, just because its ability to be around chemicals and stuff like that. They'll print in that filament. But the thing is, if you're starting to do that you're doing that change. If you run an MMU, some people run MMUs and they're intermediate. Like the guys who are running on bamboos, if we're going to stick with the bamboo topic, is you have all these filaments and you just put in your slash and click go button, right? They kind of make it where your MMU is beginner friendly, which is nice. However, when you start mixing filaments, you start doing an outer shell of PLA and an inner shell of ABS.
Oh, okay.
And
I've seen
stuff like that.
I know something. It prints one area first, and then it prints over that area.
Right.
Yeah.
If you start doing something that's near chemical and something that's not near chemical and stuff like that, you start really dealing in more of an intermediate zone. You're starting to deal with intermediate filaments. Once you start, dealing with like your nylons, incorporating a nylon in there, I think we're nylon X. You start really getting into your more advanced, because now you got to switch out parts and stuff like that inside the bamboo for it to run. But the thing is, the bamboo is notoriously, it eats filament like it's going out of style, because it poops out 95% of what you're giving it.
It's the issue with multiple material units. We talk about sustainability with your filaments. It's much harder.
Oh yeah.
These filaments get blended together when you do purging like that, and it's just hard to kind of get them back together. There is some blending acceptable, but you're not going to get the same filament back that you started with.
Yeah.
Sustainability in your intermediate filaments is a little bit harder.
Yeah.
Than your non-intermediate filaments, because intermediate filaments aren't biodegradable.
you're probably going to get some gases that get released you shouldn't inhale.
Yeah.
So
a little bit of a headache.
Yeah.
And some of it is an economical feasibility when we talk about recycling. To me, and sustainability to me is the prime example is the water bottle.
Yeah.
The water bottle has kind of tried to come up with a solution, but they do not have a solution because most water bottles still end up in the trash field.
Right. It's like airplanes.
You know, so I believe until it becomes economically feasible. So when I say economically feasible, a byproduct of oil was gas.
Right.
Someone or some company has to find a economic feasible alternative that is gas.
Mm-hmm.
So the plastic is this, and hey, we just discovered that we can do this with plastic.
Right.
You know, this is a byproduct of the plastic recycling, which will cause sustainability. Mm-hmm. I would argue that it probably even need to go to the point of like tires, where they took tires and turned tire into bedding material for gardens. You know, so they have to figure out something that has a economical use that it's worth it to a company to say, hey, well, send me 10 tons of that.
Yeah.
I think if you are a company who is specializing in additive manufacturing of any sort, if you don't have your own recycling and process in place, then you definitely need to start looking at why you're doing this. If you're doing metal recycling, we know the guys too who are doing laser sintering. That's very recyclable. So you can repeat the same process, just add new a little bit in the process and keep going, right? Until you inadvertently round. Self-looking lollipop. However, when you start dealing in filaments and stuff like that, you start dealing in the fact that if you don't have a business partner who is a recycling industry partner that will take your 3D filament and turn that back into usable regular filament again, you are in the wrong job field. You need to really think about that, because the thing is help a business grow. You know, if it's a small mom and pop business down the street that's saying, hey, I'm recycling all this and turning a new filament and giving it back to you for a cheaper price than what you paid for it, guess what? You're going to win. You're going to help them out. You're going to win in the long run. Or, partner with some of these industry leaders to make recycled filament. Partner with Sunblue, the guys from Creality that are doing it. Or any of the U.S.-based filament systems if you're in the U.S. Talk to them about creating a line of recycled filaments using your filament that you've kind of blown through.
Or if that's not feasible for a company, and I'm with you, that should be done as a responsibility for society in general. But I think maybe the solution is it's the same thing we did when we developed trash bags to put garbage in. Maybe the solution is giving the consumer or prosumer the means to easily break down the materials into a pellet form or to some form that can be easily put into some extruding system. So maybe the answer is we need a recycling. The same thing when we have a desktop 3D printing concept. There should be a 3D printing recycling concept also that a person can buy as a kit.
Phil Extruder.
I'm just saying, like, Phil Extruder is one, but I mean, like, Prusa needs to do it.
There's also
Creality needs to do it. They all, because they are the ones that's helping, that are impacting the landfills.
And,
it's not their fault that they make things and people are not being good stewards.
Is they get, there's open source stuff out there for people to learn to build it themselves. That might be your best bet. If you can't afford one of the big name ones, go build it yourself.
Yeah, until like you said, somebody steps up or somebody sees a business opportunity and says, well, hey, that's why gas is king right now. So until somebody sees that opportunity and see the potential in sustainability and recycling, then it's not going to happen. They recycle aluminum because of the process of making aluminum and the power. That's another thing people are not considering with recycling and sustainability. Is what is your footprint on the power grid? What are you consuming that way? And because you're going to dissipate energy as heat. So I mean, you have to think about these things too. From you know, if you're on a print farm, I think a print farm you're starting to get into. Hey, your requirements is a little bit different than a person that's printing one print.
Yeah,
exactly.
Yeah,
but we all should share the same responsibility.
No, exactly. I agree. I mean, with your sustainable, we should all try to do our best to not just throw it away and try to reuse it in some way.
You know, be a champion in your own industry. You know, and the thing is we see more and more industries out there not champion on industry. And the thing is, I guarantee you, if you champion your own industry, you're going to get more support.
It's one of the biggest like detractors from 3D printing is like the waste.
Be a green company when it comes to additive manufacturing. I can't tell you how many we saw at Rapid. The only problem is I can count them on one hand.
It wasn't as many as you think.
That you
probably more than there ever been though.
Probably, but the thing is you know, you say, you kind of look for their logo and you say, are you a green company because you're thinking about this. You know, you're thinking about the recycling of what you're doing. A lot of companies are trying to push for the green side. You know, a lot of guys are saying we use filaments that we can reuse over and over again. That's the metal guys, because they just add new and keep using it until it's over and over and over again. The FDM guys and the guys printing resins, you know, that's when you start running into the you buy once cry once thing. But you can tell that, you know, it's in the forefront of their minds of how do they partner with people.
I do think if that technology is ever the same way where the microwave was, you know, the size of a modern appliance, you know, a little bit bigger than a refrigerator, to where it was the footprint was reduced to what we have now. That the microwave, like I said, now is probably one of the simplest appliances in your whole house. I mean, you basically have settings where you don't even have to punch in, you know, what you want. Yeah. So I'm saying,
popcorn will burn it too. Don't worry about it.
Maybe the day comes where the technology gets to the point where we get some of the technologies that are more advanced that are in. We don't use FDM. We don't use resin because you get this technology is matured enough that it can do everything that the others did. And it's a powder base, so it can be recycled over and over.
I'm gonna say this: you know, the industry needs to do better. You know, just
we gotta figure out a way to put like we're too busy additive. We're too busy like adding stuff and trying to make something. We're not always thinking about
join together, work on something together instead of praying to God that someone else will do it for you.
Yeah.
But you know, I think that that takes us to the end, you know, this week. You know, we definitely, you know, kind of went further and further and further along the way before. You know, we keep adding and adding and adding. You know, we want you all to be, you know, excited and stuff like that when we do this. You know, I just want to say thank you. You know, we're at almost 2,000 all-time downloads. You know, we're approaching that very, very, very quickly. You know, and you know, honestly, can't wait. You know, something that we kind of strive on, you know, kind of helping out. Y'all go take a look out there, Printed Heritage. We're doing some big things there, and growing that little by little. We're kind of expanding more and more into other things. You know, go take a look at the blog. We will be adding more to that. The YouTube channel, which you probably might be hearing this on, who knows. We'll be doing more and more, we promise. We just want to say thank you. If it wasn't for y'all, we wouldn't be doing this. You know, we see more and more people from all over the globe listening in on a weekly basis. And, you know, one of these days, like Ed said before, maybe we can get out and meet some of y'all. You know, maybe we can meet y'all at Rapid next year. You know, and maybe get together for dinner or something like that. You know, we'll throw it out. You know, who knows? We may throw out an invite, you know, next year during Rapid. We could kind of get some people together for some drinks or something like that, and people who've listened to us, and you know, maybe do a group episode or something like that, do a live or something like that with everybody. But you know, it gives us a year to prepare for it. Yeah. So, but you know, from my side, I say thank you, and you know, we hope that you know we give you all the information that you want weekly, and you know, we hope we're giving you exactly what you want here. If not, please let us know. All right, y'all.
I would say that, like I said, I'm glad to be back, guys, to spend some time with you and supply some content. But I would like to see if we could get maybe some of the prints that you guys have done. You know, maybe we can get some images of some of the stuff you've printed. If you're a basic user, maybe you can share some of that if you're intermediate or advanced, or if you've done some things, you know, with some materials that we've talked about. It'd be nice to see some of the things you guys come up with.
Yeah. I mean, from my side, I always say thank you. I also agree with what Ed's saying. Like, the biggest way that we learned a lot of these things was, wait, you did what? And how did it go? Okay, well, tell me about it, and then I'm gonna take what you learned and roll it into what I know, and try to learn something new and keep it going. So that's kind of the point about a lot of this is you keep the knowledge going, you keep the learning going. So if you're listening, we definitely are wanting to grow that. So give us some ideas or anything you're working on or anything like that, and like we'd love the conversation even. So but yeah, stay tuned. Big thing, the lithophanes and stuff on Printed Heritage and things like that. Please, if you have flag prints, check it out. If you have any issues or anything like that, report it to us. We can't fix something if we don't know. So yeah, just kind of give us a heads up, and yeah, if you guys stay tuned, you'll see some more stuff coming on down the line. So, and
if y'all are interested in higher education and stuff like that, just to end it here, I may do a couple vlog-ish episodes on the YouTube channel, kind of talking about the process of getting into Purdue Polytechnic's, or known as Purdue University, Doctor of Technology program, and walk y'all through that process. So, but all right, y'all, we appreciate it. We thank you. We love y'all, and have a good one.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.